Okay, we're going to do another Cauchy-Euler example. So here's our equation: x squared y double prime minus 5xy prime plus 9y equals 0, and all the usual conditions, x is positive and so forth. So anyway, this is going to lead us now using the new method that we just did in the last video: m squared plus negative 5 minus 1 m plus 9 equals 0, which is m squared minus 6m plus 9 equals 0, which gives us m minus 3 squared equals 0, which is awesome. And that means m is equal to 3, so y1 is equal to x to the m. And of course, we're going to put a k1 x to the m and all that, x to the third, I mean, because m equals 3. But how do I find y2? Well, we're going to use reduction of order to find y2. Once we have a y1, we're going to use reduction of order to find y2, and let's see how we do it. So y is equal to uy1, which in this case is ux to the third power. But notice I'm promoting good dental health. And y prime is equal to u prime x to the third plus u times 3x squared, and y double prime is equal to u double prime x to the third plus u prime 6x squared plus u times 6x. I'm just differentiating all the way down using product rule or whatever. Now I want to take this and fit it into the original equation: x squared y double prime minus 5xy prime plus 9y. And that's my x squared y double prime, that's my minus 5xy prime, and that's my 9y. So here I get u double prime x to the fifth plus u prime times 6x to the fourth plus u times 6x to the third. When I multiply it by negative 5x, I get negative 5x to the fourth. What am I multiplying? I'm multiplying that guy right there. Negative 15x to the third. And now I multiply by 9, so I'm taking that, multiplying it by 9. For here, when I multiply by x, this line over here, I was using that line up there. Anyway, this whole column disappears, and I wind up with u double prime x to the fifth plus u prime x to the fourth equals 0. I could divide everything by x to the fifth because it doesn't equal 0, and I get u double prime plus 1 over x u prime equals 0. And I would like to make this in a nice what do you call it? First order thingy ding. So I'll let u prime equal v. So I get v prime plus 1 over x v equals 0. And I feel like using integrating factors, so I'm going to let I equal e to the integral of 1 over x, which is basically just e to the ln x, which is just x. So I multiply everything here by x, and I get xv prime plus v equals 0, which gives me xv prime derivative of the product xv is equal to 0. So xv is equal to a constant, k, which I'll call k2. And which means v is equal to k2 over x, but u is equal to the integral of v, so u is going to be k2 times ln x plus k1, and we know that y is equal to u times x to the third, which is k2 ln x plus k1 times x to the third. So y is equal to k1 x to the third, which is the y1 we got before when we first started this whole mess, plus k2 x to the third ln x, which, if you recall, is the exact same final answer we got when we used the other method, that substituting method. So there we go. It all works out good. Take good care of your teeth will take good care of you, and I'm out.